Hello, everyone, and welcome. Welcome to VW MOOC for 2025. This is our 11th annual event, and we're really excited. We're in week 1, so we just started with our first live meeting yesterday after the opening, of course, on the 4th. And today we are going to have a session from a presenter who's from Mexico. So if you've never been to Mexico, you'll get a chance to see Dr. Christian Jonathan Angel Rueda, who is from Mexico. He has a Doctor of Educational Technology, UAQ, CONACYT, doctoral scholar, and he did this in 4 years. He graduated with honors for the thesis Designing a Didactic Model to Introduce Teachers to the Use of Virtual Worlds for Educational Purposes. He holds a master's in administration and consulting and a bachelor's in design and visual communication from UMQ and a specialization in educational research from CIIDET with honors. He is a postdoctoral researcher at UPSRJ, focusing on inclusive teaching in immersive 3D digital environments. He's a member of Mexico's National System of Researchers, SNI. He's a speaker at global events, including Virtual Educa, TEDx, UAQ, and ASJ Japan. He published on AI. He publishes, actually, he has a lot of publications. You might want to search him out with the research AI, just write his name. Ethics, Virtual Worlds, 3D Immersive Digital Environments, 3D IDE, and XR-based education. His publications are also available on Google Scholar. So it gives me great pleasure to have you with us once again. So I'm going to stop screen sharing. And there you are, our presenter from Mexico. And I just want to say that your work is being cited by my students. And the problem is that it's not it's not current, but they love your work nonetheless, and they use it in their writings. So thank you.
Thank you very much, Dr. Nellie. Thank you for the opportunity to being here. And I don't know if my presentation is looking right now. Can you
It's
say?
looking great.
Perfect. Well, thank you for the presentation. It's an honor. Well, I will be presentation. Good morning and good afternoon. If if we are in different places right now, everyone, and thanks you for joining me in this session. The title of my presentation is Advancing Robotics Education Through Immersive Digital Twins for Case Studies in EdTech. This is Immersive Digital Twins, and this is so important for me because it's part of my research from the postdoctoral. And this research is, I am with some students that are making his postgraduate studies, and well, this is the important thing about this research. Today we are going to explore how 4 pioneering initiatives, I will say the name of these researchers is VirtuArm, MapTwin, NeuroDrive and XR-Auto. This is 4 projects that we make the last year, and I will present to you how we make it and many elements that we will looking about that are redefining robotics education through development of immersive digital twins. These projects have been developed with the framework of extended reality platforms and sustainable engineering practice, and they present not only technical innovation but also educational strategies for bring
Excuse
the
me,
gap.
Christian, your finger
Yeah.
is showing and YouTube might not like that.
Ah,
Sorry.
excuse me,
Okay.
excuse me. Let me, I touch this. I touch well, ahí está, yeah, yeah. Excuse me. Okay. Um, um, I, I remember in which part I was. Okay. Um, um, This project has been developed with the framework of extended reality platforms and sustainable engineer practices. And they present not only technical innovations, but also educational strategies for bridging the gap between theoretical knowledge and practical applications. Let me change. We will look at next. We will look at each project and in detail examine the methodology behind them and discussion of the implication for scalable technology exchange learning in a robotic education. Okay, well, here is, I put the main ideas here for the introduction of these projects. Uh, this is the introduction to the immersive digital twins. Uh, to build, let's briefly of this, what mean by an immersive digital twin or IDT. In the context of robotic education, an IDT is a high fidelity interaction, three-dimensional replication of a physical system. It operates in real time and synchronized with a real-world counterpart and is often deployed in the extended reality environment, is in the real world and in the virtual world. This is a virtuality, uh, augmented reality, or mixed reality. Depends of the project and depends of the technology we are using in that. This approach uh, has three major advantages for education. First, it allows safe experiments where students can manipulate systems without of risk and damage and injury for the development of these situations. Second is facilitates interactive learning. Students can test, fail, and try again. This is so important because when I look the students were making in robotics, it's so difficult changing many things, and in the computer robotics things is so difficult when are changing the elements because it's the time of this situation when we're studying robotics. But when we are making in digital the same way and connecting to the real world, they can first fail, and try again, and refining their understanding through cycles of practice in the virtuality and then connected to the real robot in the real world. This, I like very, very much that when I make this project with the students. And third, it enables scalability and accessibility. Digital twins can be accessed remotely, allowing participation beyond the construction of a physical laboratory. And well, this is important for the main idea. The projects we will see today take these principles and apply them to a different context, ranging from robotic arms to autonomous vehicles, each with a clear educational purpose. Well, next slide. Okay. The first case of study one, VirtuArm, physical and virtual robotic arm integration. Our first case study is VirtuArm. This project integrates a physical robot arm with its virtual counterpart through bidirectional control. The system uses sustainable engineering practice, recycle materials from parts of the physical structure, and incorporates six servo motors for precise joint control. On the virtual side, the robotic arm is modeled with Roblox, and well, this is so important. The connection between real robot and the virtual robot is a grateful thank you for the virtual world Roblox. Roblox was for so accessible platform that supports extended reality features, and that is so important for this project. Roblox was so important for this project about that situation that is accessible platform, very accessible platform. Like in Mexico is so accessible. The two components, physical and digital communication over a network allowing real-time synchronizations. This means that if you move the physical arm, the virtual model mirrors the movement instantly and vice versa. This mirror, well, it's not exactly in milliseconds, it's in seconds, 1 to 3 seconds. But we're trying to depends of the maybe depends of the connection. We're finding about that it more be more exactly in that. But for educational purposes, is very well. Uh, for education, this allows students to work both in person and remotely. This is important. They can test code or control sequences on the virtual arm before applying them to the physical system, reducing wear and tear and encouraging confident experimentation. And that's great for students. This is the case one, and then I will change to case four, case two. Okay, virtual arm outcomes and challenges. The key achievement of VirtuArm is a demonstration of smooth, low latency and synchronization between the physical hardware and its immersive digital twin. For a teaching perspective, it has enabled robotic students to explore concepts of kinematics, motion control, and automatization in a risk-free yet authentic environment. It was also lowered barriers for students with limited access to physical labs, as they can participate entirely via the virtual interface. Challenge includes dependency on stable network connection, which can affect latency and limitation of the virtual environment's physics engine, which sometimes struggles to replicate complex force integrations. These are the 3 points that I look about this project. Okay, the case two, MapTwin robotic mapping in hazardous environments. MapTwin addressed a different problem: how to train students to use mapping robots in hazardous or inaccessible environments. The concept is to deploy a model robot equipped with a ultrasonic sensor and a navigation algorithm of SLAM, simulation, localization, and mapping, while simulation, generally, and digital twin of the environment in always in Roblox, okay? In education, this allows students to observe and participate in real-time mapping exercise, even if they are not physically present in the environment. This is why, okay, we look in the physical, the robot, but we can change the difference in the virtuality. It also supports scenarios that are too dangerous or expensive to replicate in school or university settings, such as post-disaster search and rescue training. Let me put the next slide. The outcomes and the challenge of this MapTwin. Uh, the MapTwin has a successfully demonstrated accurate environment replication, allowing users to navigate and interact with the mapped space in the digital twin as it's being created in reality. Yes. The benefits for education are clear. Students can see the mapping process unfold, analyze sensor data in context, and understand the constraints of autonomous navigation. This is also so important. The challenge here is including the optimization of the SLAM algorithms for different environments. Dust, debris, and uneven terrain can still confuse the system, and ensuring the compatibility between sensors outputs and the X-Real visualization platform. This was a complex situation because when we change from different contexts of environments, maybe the real robot is not clear about in which part are when the situation is in the virtuality. This is a challenge that we have to look how we can solve that. But well, I will change the next. Here it is. The case study 3, NeuroDrive. This is the most complex of the projects we have. Was an open source autonomous driving with digital twins. Well, autonomous is not so autonomous because it's complex to be autonomous for the students and make it autonomous with open source scripts that we can find about that. But that the NeuroDrive takes us into the realm of autonomous driving education. The aim is to develop an open source, small scale autonomous vehicle platform that can be integrated with a digital twin for training and experimentation. The prototype vehicle use well in English I don't know how I can say it's ESP32 microcontroller, Raspberry Pi, and a combination of sensors including ultrasonic and camera modules for object detection. The long-term goal is to link to a virtual environment in Roblox so that every movement, obstacle, detection, and control input is mirrored in a digital twin. We can put many obstacles in the digital uh, in this virtual twin, and we can look how is the difference when it is looking in the real world and the twin in the virtuality is looking how it reacts in different ways. It's interesting how we can look and we can study how is the reaction of this open source autonomous driving in the digital twins. Uh, and in Roblox, it's interesting how we can look about the movements. It's not exactly the same. Well, we can look at about that in the challenge about that. Well, this means that students can develop and test control. The most important of this project is the test control algorithms in the virtual model, then deploy them to the physical vehicle without major adjustments. This is the most important thing that we look about this project. Let me see. The next, here it is. Well, the outcomes and the challenge. Okay. Initial trials with NeuroDrive have, have shown effective autonomous navigation and remote control capabilities on the physical prototype. The open source approach makes it accessible to a wide range of academic institutions and hobbyist groups, encouraging collaborative improvement and knowledge sharing. Here in my university, we look at different groups when they look the facilities to be making tests in these virtual worlds. They say we make it. They like very much. Uh, Current challenge include the ensuring that the digital twin resource feedback in real time and scaling the system for more complex multi-vehicle scenarios. This is the most interesting thing. The multiple vehicle scenarios, because the feedback we have it about the real time and the scaling system. And the challenge is to be how we can integrate and modify the scenarios in the virtuality to help the how to can scaling the system for more complex of these projects. Well, I think about that and I like very much these ideas. Um, let's see the nine. Here it is. Uh, XR-Auto Sky Vehicle Digital Twin. The XR-Auto is also in a vehicle domain, but with a focus of physical virtual synchronization for scaled vehicles. This project builds a small-scale vehicle equipped with ultrasonic sensor for obstacle detections, connected to its digital twin in Roblox. The link allows real-time feedback, include obstacles alerts via sound both in the physical vehicle and in a virtual environment. In education, XR Auto enables students to explore the principles of automatizations and robotics in transport systems without the cost or risk of working on full-scale vehicles. We like about this project because these full-scale vehicles in a virtuality and the twin in the reality is very successful. Look at how can we can work and look the details that we cannot look exactly in the real world, but in the virtuality, in the virtual worlds, yes. And we notice and the teachers and students that look robotics about these systems, they can understand and maybe look different ways to make new systems and scale the system exactly. Many things about like the image are here in and look these modifications. But but always is a but. The XR Auto outcomes and challenge we have 3 points. The first, the project has successfully demonstrated reliable physical virtual synchronization and effective obstacle detection. Yes. Well, exactly no, but is effective obstacle detection. It opens up possibilities for courses in intelligent transport system, logistic automatization, and smart city infrastructure for making tests and this is how can I say effective integration, emerging opportunities. But the challenge or the next step that we can say it include the expanding the sensor suite for more complex decision making and improving the relation of the virtual driving environment. Yeah, that's maybe the sensors, the difference with the sensor in the virtuality and the sensor in the real world have changes because we try to simulate the similar sensation about the sensors, but maybe it could be I don't know. It could be the next step of how can we find to be more realistic about this in the virtual worlds. But well, some of the next steps. But for education purposes, it's not problem. Maybe if we are in the industry, maybe it's yes, it's a problem. But with a didactic situation, it's not a problem because the student understand how can help these procedures, and well, something like that. Um, Let me see the next. Okay, comparative analysis of the four projects. Okay, we have a common strength and difference and limitations. Uh, we have first a reflection about these two analyses. When we compare these four projects, several of them emerge. They all use relative low-cost hardware, SP32 boards, Raspberry Pi, and accessibility XR platform like Roblox. The priorities: accessibility, enabling students to participate remotely or in resource-constrained settings. They are grounded in real-world applications from industrial robotics to autonomous transport. However, there are also distractions, like in VirtuArm is centered on manipulation and precision control, but in MapTwin on environmental mapping, in NeuroDrive on autonomous navigation, and in XR-Auto on transport automatization. Understanding this context, this diversity shows that the flexibility of immersive digital twins as an education technology. In common strength, utilization of low cost, integration of XR, scalability. The difference, variety of application across the industrial. And that second, this X, addressing common challenge and lessons learned from each case of study. Okay, I will change the 12th. Educational blueprint for scale XR digital twin robotics. From these case studies, we can propose a blueprint for integrating immersive digital twins into robotic education. Define education objectives. Start with the skills and knowledge you want to acquire. 2. Choose accessible hardware. Choose components that are affordable and widely available. 3. Develop the digital twin alongside the physical prototype. This ensures synchronization and parity from the start. 4. The interoperability test and refine. Gather feedback from students, measure learning outcomes, and adjust accordingly. And implementation, interactive testing is about that. And I can say like 5 points. That could be like plan for scalability. That is where we are looking right now. We have the first prototypes, and we are looking how we can be looking for scalability. Design system that can be expanded in a complexity or replicated in other institutions. This is why we're trying to do that right now. Uh, it's not easy, but it's so success. Well, I like very much the when we have troubles about that, and we say we can do it. We can do it. Yeah. Well, future directions in EdTech robotics. Uh, Looking ahead, immersive digital twins in robotics will likely be changed by artificial intelligence for more autonomous behavior by more realistic simulation environments and by cloud-based XR platform that allows students to access and manipulate digital twins from anywhere in the world. This is so interesting because now right now the universities is not only in our countries. We can connect different countries in different ways with these projects and other projects with the virtual worlds. And this was the most important thing that I loved about the virtual worlds right now. The converge of robotics, artificial intelligence, and XR or mixed reality make it possible to simulate complex multi-agent systems in industrial process and even in turn smart cities for educational purposes. Right now, the first thing that I look with Rec Room, the virtual world of Rec Room, I look that they have a new agent to make worlds or to be your partner in all the games that are in the virtual world of Rec Room. I look that if that put in Roblox, it will be blowing my mind. But with all these things that I say to you with about connecting uh, extended reality, mixed reality, uh, in between the real world, virtuality, virtual worlds, multi-users, with robots, connecting a real robot with a robotic robot in virtuality. Well, we can do many things about that. But but with artificial intelligence, well, many things. Uh, Conclusions. In conclusion, immersive digital twins bridge the gap between theory and practice, offering safe, scalable, and engaging way to learn robotics. The four projects we are examining, VirtuArm, MapTwin, NeuroDrive, XR-Auto, demonstrate how this technology can be applied in diverse contexts while adhering to the same educational principles. My hope is that these case studies will inspire further adaptation and innovation in this exciting field. And well, uh, I'd like to open the floor for questions. I'm happy to discuss the technical aspects of these projects, the pedagogical strategies, or the practicalities of the implementation them in a different education settings. And thank you so much for your attention.
Thank
I
you.
will.
Thank you so much, Christian. This sounds fascinating. Is it only you're only researching young learners, or is this applicable to adults, for example?
The idea is to adults and new students for the university, but it's for all. The idea is for all.
So for all ages.
Yeah.
And who is currently participating?
Well, right now, I have two teachers of robotics that are helping to me to understand the technical issues about how can we connect the elements from the real world to the virtual world and how we can make simulations in the virtual world and help to them to the real world or connect in the same way because like extended reality we can say to the robot from virtuality say please move uh, well, different directions in the virtual world, and in the same way, is the movement maybe in seconds look the same way the robot in the real world is moving like a twin in the same way in the virtuality. Uh, The problems that we have it is when we put obstacles. We look different ways how they understand the obstacles in the virtuality and the difference in the real way. We have a problem because if I put a mouse like an obstacle in the virtual, they say, mouse. Well, they don't know that the system don't understand it's a mouse. It's like an object and it's little. But in the real world, it's more bigger than in the virtuality, and the scales are different with centimeters maybe or millimeters, and change the different reactions. And we say, oh no. But these things help to understand students and teachers how can they make solutions. Maybe not like these things that we are making right now is for the industry, but because if we go to the industry using these elements, maybe it's not useful because have many problems in the interactions. But when for didactic situations, for understand what things have problems, how can we solve the problems, and something like that is more interesting in a didactic situation. And this is why these twins about virtuality and reality helps for a teacher explain which is the problem in the programming situation, and they help it to the teachers.
So the idea is to have this kind of communication, to have a discussion on the possibility of resolving these issues. So the problem is the important part. The issues
Yeah,
are what's important here.
the
That's the
issues.
idea.
Yeah,
The issues are
yeah, yeah.
important.
The most important. Yeah, exactly. Right now, maybe in the future, no, but
Yeah.
right now it's helping to us.
What about AI? You mentioned AI. AI would have no problems, visualizing and identifying the object, whether it's small, large, or whatever, it would have no issues at all with this.
Well, we can put the two ways to use the AI in different ways. For education purpose, we can use the AI like our friend that helps to understand in the main idea we are programming something. No, you have problem about that, or please test, make this test, please, and you say check the test. No have a problem. You can check this formula or something like that. Please check it, and it's trying, and the AI can help testing all the process. But the other way is to programming the AI for robotics and say explain it, please, the NeuroDrive. Please, I program it that you have a space of 3 kilometers and you have to make many tests and you have to uh,
Navigate.
navigate and make many tasks. If you don't complete the task, you have to repeat it and repeat it. And in virtual world, they can repeat in infinite ways, many times. That in the real world, it will be making a cost because in the real world, it many times maybe have problems with maybe with the battery, many things that in the real world having problems. But in the virtuality, the AI can make many tests that the AI wants in the real world is more difficult. And
Yeah.
they can help many tests here, and then you have a perfection. Yes, come on to the real world and do it well.
Christian, you were talking about virtual worlds at the end, but then at the beginning you mentioned virtual reality. So are we talking about virtual worlds? And if so, what worlds? And if it's virtual reality, that's another story. So I'm kind of confused.
No problem. Roblox right now is having the process. We can look at the Roblox in virtual reality or in our computer or in our smartphone in different levels of immersion. And this is why we like very much Roblox because it's for easy for connect the 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 robots in the real world to the virtuality. I don't remember how the language of the connection is Lua, something like that. Well, it's easy to connect robots with this virtual world Roblox, and the persons can connect in virtual reality or in different ways of immersion. This is we decide to use Roblox in this time.
Oh, okay.
About
Okay, so we're not talking about virtual reality. As such, we're talking about the ability to use any kind of with a headset or without the headset
exactly.
to make it easier.
Yeah.
But virtual worlds is not really the same as virtual reality worlds. It's kind of different.
Well, Roblox, yes, is the we can make the example. Sansar and Roblox.
Exactly. Yeah.
Sansar begins in virtual reality and then change to the computer and then change to
Oh, they
another
did.
ways to connect.
Yeah. Mm-hmm.
And Roblox is different way. They connect first in smartphones, in tablets, in computer, and finally we connect in VR. And yes,
Mm-hmm.
the connection is not the same. Yes, but the sensation of immersion is really good when we connect and try that connection right now with virtual reality. Maybe with a new changes that I are making in Roblox, the new bodies they make with the avatars, maybe it will be similar, not exactly like the VR software like Sansar or the other
Special.
spatial, something like that. Yeah.
Yeah. With a Ready Me player, maybe have Ready Me player avatars.
Yeah. More realistic. Yeah,
Yeah,
yeah.
yeah, exactly. I think Adobe has a way of making these avatars. There's a question that Val asked if it's possible to visit the Roblox that you're using. Would that be, or there's
Okay.
privacy issues with that? Or
Yeah.
can we see it? Can we at least see it?
Well, Rain, I don't have my, excuse me, this time with I don't have my computer.
Oh, that's right. You mentioned that.
Yeah, you mentioned that. I am in a tablet. This is why I cannot connect easy way with my Roblox. And yeah, well, it's a project that is all right now is not finished. Is in a beginning demo, and maybe in the final, no, in 1 year maybe we finish this project. We have many tests and tests to show to all the people, and excuse me for about that to the
Okay, so
people that
next year, we'll have something to wait for next year when
yeah
you maybe
yeah.
are you planning, is this going to be completed by next year or you don't know how long it's going to take?
Well, the idea of this project is how to is I use it for my model. I have to finish a model, a didactic model, to help the teachers make these things in robotic. I or not only in Roblox, it will be in different platforms. The next weekends, I will show with a collage, two college, two teachers. We showed two other projects from that we use it to share how can we connect these situations. Maybe we can show a demonstration. Maybe I don't know. Let me talk with the teachers and I will be presenting the next weekends with the two teachers because I have two different presentations that are coming on. Maybe I show more things that will be similar like today. Well, right now all the research that I make with my college, these professors, and with my students is for making a didactic model to how to use these virtual worlds in different immersive situation for or the context of teaching robotics in these elements. This is the main idea to explain the teacher that it's easy, it's not difficult. This is why I explained in my presentation that we decide Roblox because Roblox have right now uh, many easy ways to connect or program in easy ways and not problem to connect with real world and robotics and something like that. That's why we decide
Yeah, because
right
it's very
now.
physical. It's very physical. It's not virtual at all. It's far from virtual. But it's you know, it's I guess something that you don't see every day. I mean, you know, unless you make your robot look like you in the future, maybe.
Maybe.
But they're doing a lot of work on robotics. But I know that schools around the world, I don't know if you can add in the chat if your school has a robotic class, either during school, part of the curriculum, or maybe after school. But I think it's quite popular. So the teachers that you work with are teachers who teach robotics in to young learners. Is that it?
Yeah,
Yeah.
yeah.
So you know what? This would be very, very interesting to other teachers around the world, not just in Mexico, because I
No,
think
the idea is for all the teachers that teach robotics and well, the idea is
globally, not just yeah.
globally. Yeah, exactly.
That's exciting. I mean, I was involved a little bit in robotics with one of my classes that I was teaching. They had a robotics class, so I was kind of involved. It was after school, and I had to encourage them to come, make sure that they showed up. They were 14, no, not 14, yeah, 14 years old. It was a grade A class, and it was really exciting. I mean, they loved it. They would come, you know, after school, even though they were tired and everything, but they loved it. But I think you know, this this subject is developing, and you're making a difference. So you know, I think it's if others are going to find out about it, this is going to be great. So it's going to be a program for teachers who teach robotics.
Let me see. Let me if you give me the opportunity, I will show is um, uh, a place that we publish the first ideas of this research. Let me share the link. I can share. I will see here. I can share. Uscita ventana. Tudum. Here it is. We publish. It's in Spanish. We publish in this. It's from the diffusion our for the students. Is the first. Here is Trambet is our laboratory. It's a electronic uh,
So if you can share
place.
that, we can translate it. I mean, we can get an AI tool to
Yeah,
translate this. So can you share it in the chat? Is this
this
something
is a
on your
project.
computer? Is it on your
This is
computer?
no, it's in a web.
Yeah. Do you have the link? It's
Yeah,
open
yeah, yeah, yeah.
access, right?
Yeah,
So if
it's
you
open
could,
access.
okay, so if you could share the link, we
Yeah,
could, I mean, today, it doesn't matter what language you publish in. We can always translate. I mean, like,
yeah. It's a thing that let me see you the here is the project. This is no. We have other projects that we will show in the next weeks. This is not only from robotic, but here is a robotic. This is the first with VirtuArm. These are the real robotic, and
yeah.
this is the virtual robotic in Roblox. We've played here some elements. we we don't write. The students that help and make the project, they write it, and we help to explain how to write. This is the first main. This is the car. This is our car of MapTwin. This is the MapTwin, and this is the Roblox, and this is the MapTwin in Roblox.
So this could be used in augmented reality too, right?
Yeah.
This will be great on for students on their smartphones.
Yeah, and this is the NeuroDrive. This is the connection that they have to understand the element that they have to look at. And this is another. Here is this is the XR-Auto. This is another, and this is the in Roblox. It's a special issue of this place. This is the explanation of this issue. And well, we have 10 projects, 10 different projects, and I show of these 10 projects, I show 4 of robotic today.
Thank you. Thank you so much. Thank you for all of this and all the work that you're doing. You can stop screen sharing.
Yeah, excuse me.
Yeah. All right. That was really exciting. Are there any questions? I think Val had a question about privacy as well. Val, do you want to ask your question by voice?
Sure. I think you answered it when you talked about the model and the demo, because I do worry about Roblox. Kids can meet all kinds of strangers there. Do you have any concerns about privacy?
The privacy, well, yes, it's difficult. This is why right now the project is in beta and in closed beta, because yeah, the privacy maybe will be difficult. Yeah, right now is the privacy, and when we look all the bad things that the persons do with artificial intelligence and in the virtual worlds and many things, oh my goodness, we have to write about that and do
Yes.
something because it's so awful the things that the persons are doing. We can try to do good things, and other persons doing with these good things bad things.
Yes.
I don't like
That's the
that.
problem.
One other question. You and I agreed totally with you when you said Second Life is VR. It is virtual reality. It's just you don't need that cumbersome headset. Eventually, because I've had 2 headsets, I'm on my 3rd. I don't like it. You're trapped. You don't have your interface. So I think you agree, and I think people can argue the point. But to me, when you're immersed whether you have a headset or not. And I'm just as immersed in Second Life as I am with my headset. VR desktop, I prefer.
VR disco. Yeah.
Desktop on a VR. I want a big screen. But
Big
I don't know.
screen.
Nellie, you were kind of saying they're 2 separate things. I think it's a great argument. Bringing up the argument.
And I look my arms, my body, and interaction and all. I go out. I go in another reality. My brain said, "Oh, this is a new." I smell the new reality, something like that. But it's a brain. It's a brain, and I'm studying about that. I have some articles about that of the different ways because we don't need the glasses to have the process of our brain to be connected in the reality of these virtual worlds. The brain, well, when we read a book, we make an immersion because our brain is totally make many things. When I am my first steps in virtual worlds and I go to Second Life, my brain go with and I've been immersive in this process. Maybe in third person, but my brain when I was very connected and talking and walking and doing many things, my brain say you are there in Second Life. You are walking in Second Life because my brain connect with the virtuality. I don't need all these headaches. And no. It's not the brain is successful. The brain is maybe we have to study the brain in many ways because the brain, yeah, it's different way. We understand the things when we put our glasses and something like that. But our brain decide because person said, I don't like the glasses. Okay, because your brain decide that this is not real, and you need the real. When you put the new glasses that come the next year about augmented reality, that you can be from Google Glasses with artificial intelligence, and will be looking things and elements in virtuality. Many persons said, I like more this. Well, yes, because it's not heavy first, and we can interact with artificial intelligence, and maybe the avatars, we can look real and virtuality. Well, it's other different ways, but I prefer that person decides. This is why when I try to explain about virtual worlds, I like virtual worlds when when the virtual world have different ways from connect. If you don't like to use the glasses, no problem. You want to connect with a smartphone because you like more the smartphone, connect with the smartphone or connect with your computer. But the important thing is to connect to the virtual world that have the liberty, that is synchronized, that is multi-user, that is synchronic, asynchronic, all the elements that have virtual worlds. That is wonderful. We have to put many money right now.
Yeah,
And
so
other virtual
it's
worlds,
expensive.
it's expensive. And in other virtual worlds, it's more easy to make projects and not have to put many money. This is my
what
first
is
problem.
free? What are some of the ones that you recommend that are free for both Android and for the iOS, not just for the Android?
Well, I like very much Roblox. I like very much Rec Room. I like very much Spatial. These three platforms I like very much because it's multi-platform. We can make more easy. Maybe especially have to spend, but it's no problem with that because you have three spaces to make free, and well, I'm trying to explore another virtual world that is frame VR. I'm trying to use it. I have my issues about that, but my first to connect quickly is Roblox, Rec Room, and Spatial.
Yeah, I love Spatial too. All right. So everyone try it. Just put it in Google search, in a Google search engine, and you'll get it. All right. So thank you so much. I hope you feel better.
Thank you.
So we can get you back here as soon as we can, maybe in another area.
I will come in the next week with my other college, with my professors.
That's right. You're going to be back with.
Okay,
great.
With the two professors,
two colleagues. Okay, wonderful. So I hope you feel better, and we'll see you then. Thank you, everyone. Thank you for joining us today.
See you
tomorrow. Yeah. Thank you.
Bye.
Bye.